Hey Chemistry, Mrs. KJ here. Today we are going over Lesson 5.02, Balancing Chemical Equations for Core Chemistry. Chemical equations must be balanced to be in accordance with the law of conservation of mass. Mass is conserved in chemical reactions. To accurately represent that fact in a chemical equation, the equation must be balanced. In other words, we numerically need to show that we have the same amount of each type of atom as a reactant and as a product. A balanced chemical equation has the same number of atoms of each type on each side of the equation, reflecting the law of conservation of mass. So, chemical reactions are described through chemical equations, which must be balanced. They show the amount of the reactants and the amount of the product. Goals. Balanced chemical reactions relate the idea of conservation of mass to the need to balance chemical equations. So, this would be a good sentence to write down in a slightly different form. The reason why we balance chemical equations is to show the conservation of mass. Identify if an equation is balanced and write balanced equations to represent chemical reactions. So if you want to go in to the lesson to get that, you are more than welcome to. And we'll start with the Explore. So again, if you want to use the study guide to take notes, you can. A chemical equation must reflect the law of conservation of mass. This means that the mass of the reactants is equal to the mass of the products. Any chemical equation you write to explain a chemical reaction must show that the mass of the products is equal to the mass of the reactants. In other words, for each type of atom, the number of atoms on the reactant side of the equation must equal the number of atoms on the product side. Wood and oxygen are consumed in a fire, but an equal mass of ash and carbon dioxide is formed as the products. Not every chemical equation is balanced the way it is written. Aluminum oxide is made by combining aluminum and oxygen. So aluminum plus oxygen, how do we say that arrow? Yields aluminum oxide. But when we write it, we have Al plus O2 because oxygen is a diatomic gas. Diatomic, 2 atoms, yields aluminum oxide. And if you notice here, we have 2 atoms of oxygen as a reactant and 1 atom of aluminum. But over here, we have 2 aluminums and 3 oxygens. This expression is not a balanced equation. There's 1 atom of aluminum on the left, and there are 2 atoms of aluminum on the right. There are 2 atoms of oxygen on the left and 3 on the right. This violates the law of conservation of mass. I kind of wish I had cool sound effects now, but I don't. So the equation shows the products and the reactants, but it is not balanced. The mineral corundum is composed of aluminum and oxygen, among other elements. Now I switched to my whiteboard here because if you keep going through the lessons, they do them in a different order, but I liked this one as our first one to start with. So I want to teach you how I would balance chemical equations. My rules for balancing chemical equations is you can only change the coefficients, and of course the end goal is to have the same amount of each atom, of each element, on both sides. So let's review. These numbers right here are called what? Subscripts. We never, ever, ever touch the subscripts. We can only add coefficients. And where do coefficients go? They go to the left or in front of the entire compound. I can't add a coefficient in the middle. No, they go on the left side. All right, so how I like to do them is start by writing down your equation. I realize that takes an extra 30 seconds, but especially when you're learning, it's worth the time. Then underneath that, I write down all the elements that I have. And I write them in the same order on both sides. And I'm writing equals because I want to start out with how many atoms of each I have. So right now, how many atoms of hydrogen do I have on my reactant side? So my subscript of 2 tells me I have 2. And how many oxygens do I have on the reactant side? 2. How many hydrogens do I have on the product side? 2. How many oxygen atoms do I have on the product side? 1. So now I can easily see I have 2 hydrogens, those are good. I have 2 and only 1 oxygen. I don't want 1 oxygen. I want a total of 2. atoms of oxygen. So I have to add a coefficient that's going to change my number of atoms to 2. Now remember, let's say I had 5 H2O. How many atoms of oxygen would I have? Well, you distribute, right? We're multiplying. So I would have 5 total atoms of oxygen. And how many total atoms of hydrogen would I have if I had 5 molecules? 5 times 2 equals 10. So let's go back up here. I want to take the 1, which I already have. I want to multiply it by something and get a total of 2. So what am I going to multiply it by? 2. Whatever we multiply it by is our coefficient. That's why I changed to the red ink, so you know which 2 I'm talking about, because there's a lot of 2's in this problem. All right, so look what else happens. When I change this coefficient in front of a compound, I have to distribute it. So now, not only do I have 2 atoms of oxygen, but now how many atoms of hydrogen do I have? Well, I have to take that same thing, and I multiplied it by 2, so now I have a total of 4. So I messed up my hydrogens. Oh, but that's easy to fix. So now, instead of 2, I need a grand total of 4 hydrogens on the reactant side. So what am I going to add in front of the H2? So what am I going to put as my coefficient? I'm going to put a 2, because 2 times 2 equals 4. Now I have 4 atoms of hydrogen on both sides and 2 atoms of oxygen on both sides, so it is balanced. Woohoo! If I were you, I would get some different colored markers or pencil colors or whatever, and use different colors, especially when you're starting. And the other thing I do is once I got them balanced, I like to just kind of put a square around them, so when I'm all done, I can be like, yep, check it, I'm good. All right, let's do another one together. So this one, I have Cl2, that's an L, plus LiBr yields LiCl plus Br2. All right, so what am I going to do to start? I'm going to start by making a list of all of my elements on both sides. And I'm going to do that same list in the same order. So if you noticed on the product side, the lithium is written first, but I want to make things easy on myself, so I list them in the same order. All right, how many atoms of chlorine are on the reactant side? 2. How many lithium atoms are on the reactant side? 1. How many bromine atoms are on the reactant side? 1. How many chlorine atoms are on the product side? 1. How many lithium atoms are on the product side? 1. How many bromine atoms are on the product side? 2. All right, so let's check it out. Now, usually I say do your oxygens and hydrogens last, but in this case we have no oxygen, no hydrogen, so let's just start at the top. I have 2 chlorines on the left. I need 2 chlorines on the right. So I want a grand total of 2. So what am I going to multiply by? I'm going to multiply by 2, so that's my coefficient. Where does that go? It goes in front of the entire compound. Because I did that, what else did I change? I changed the number of lithium atoms, right? I got to distribute it for the whole compound. So now I have 2 lithium atoms. All right, fine. Let's change the number of lithium atoms on the other side. My chlorines, though, are currently happy. Woohoo! Lithium. So I want a total of how many? 2. So what am I going to multiply by? 2. And where am I going to put that coefficient of 2? In front of the entire compound. And what else does that change? It's got to distribute. So it also changes the number of bromines. Yeah, sound effects makes it way more fun. 2 bromines on each side, 2 lithiums on each side, 2 chlorines on each side. And we are done. Yay! All right. So we're going to go over 2 more that are a little bit harder. Okay, what are you going to do first? Well, you're going to write this down on your piece of paper, and then you're going to write down how many atoms of each are on each side of the equation. All right, so on the reactant side, how many carbons do we have? 1. How many hydrogens? 4. How many oxygens? 2. On the product side, how many carbons? 1. How many hydrogens? 2. How many oxygens? 3. Did you get that one? Because there's 2 here plus 1 over here. This is the only time we add when we're balancing equations, is if we have the same element in 2 different places. So we have to add for a grand total. So we have 3. All right, let's start with hydrogens. So I have 4 on this side and 2 on that side, so hopefully that's a pretty easy. What am I going to add? Oh, I shouldn't say the word add, sorry. What am I going to make be my coefficient? So I have a grand total of 4 on each side, 2. And where am I going to put that 2 to show that? Right up here in front of my H2O. What do I do next? I say, well, I have 2 times 2 is 4 hydrogens, but I got to distribute. I also now have 2 oxygens here and 2 oxygens here. So 2 plus these 2 means now I have a grand total of 4. So just cross it out. That's what I do. Just cross it out because it doesn't matter at all that I started with 3 over here. All that matters is where I am at right now, and right now I'm at 4. All right, so, that actually made it easier, didn't it? Because I want a grand total of 4 oxygens now on both sides. So what is my coefficient going to be? It's going to be 2. And where am I going to put that? Right up here. Okay, I promise you it's not always going to be 2s for the coefficients. So I look, 1 carbon, 4 hydrogens, 4 oxygens. And that one was done. So let's go ahead and start the next one. So I have aluminum plus dioxide yields aluminum oxide. So make your list. How many aluminums are on the left side? 1. How many oxygens are there? 2. How many oxygens are on the right-hand side? 2. Oops, sorry, I said oxygens, didn't I? Aluminum, sorry. And there are 3 oxygens. All right. So what do you want to do to balance it? So if we take a look at the aluminums, we want to go from 1 to 2. So how would we do that? We would simply say I'm going to multiply by 2. 2 would be my coefficient, and voila, I am done. Okay, but now we got to do our oxygens. I have a 2 and a 3. Now, your coefficients have to be whole numbers. I can't do like 1.5. It's got to be a whole number. So there are no whole numbers that I can multiply 2 by to get 3 or vice versa. So you're going to have to do a multiple of. So whenever you get a 2 and a 3, and they're the last things left, usually you have to double the one side. So what I mean by that is I'm going to put a 2 in front of here. What does that do? Well, that changes my aluminums to how much? 4. So cross it off. That beautiful purple box, it's gone. And how many oxygens do I have? So 3 times 2 gives me a grand total of 6. Okay, now how many total oxygens would I need on my reactant side? 6. So 2 times what is going to give me 6? And it's going to be 3. So I'm going to put a 3 up here. But what else am I going to have to change? I need to get rid of this 2. I need to start this part over, and what's going to be my coefficient in front for a total